Welcome once again to Stop the Algorithm, our second edition. Today we're talking subtraction. I'm going to show you why I hate to borrow and carry and things that make no sense, and why we should be working top to bottom, left to right to make it easier for everybody. So we're going to first look at the old way we did things, which I'm sure many of you are familiar with, and probably all of you. Same thing we've always done since the old schoolhouses in the Old West. And there was nothing else to learn. Okay, so here we go. 812 minus 436. Now, we all know these are the important numbers. The bigger the number, the more important it is. Our brains understand that. Unfortunately, when we teach it, we don't start on this end. We start over here. So, first step is I can't take 6 from 2. So I have to carry. I have to borrow. So I'm not sure how it works, but I'm going to cancel that out and make it a 0 and put the 1 up here. That way I can do 12 minus 6. Is 6. Now a lot of teachers don't even teach that that's the 10. It's just this is how we do it, so do it. Now we're stuck with 3 from 0. Once again, we were told we can't take 3 from 0, which isn't true. We can do negative numbers, but for this method we're going to put a 10 up there, cross this out, make it a 7, and then 10 minus 3 is 7, and 7 minus 4 is 3. And there's our answer. Now I'm not saying this doesn't work. It does work. It just doesn't make sense. And it doesn't do it the way our brains do it. Our brains think left to right, important to unimportant. The 800 and the 400 are the important numbers, not the 2 and the 6. And it doesn't introduce negatives. It doesn't introduce the idea of a difference, which happens in story problems later on. So let's look at a new way of thinking and of writing new, evidently. Same problem, 812, 436. And this time, let's start over here where it's important. 800 minus 400 is 400. Now, we look at this one, 10 minus 30, because this is at the tens column, so this is 10 minus 30. I can't take away 30 from 10, but everybody in today's society knows I can go $20 in debt. So I just say the difference from 1 and 3 is 2. See, they're 2 apart, therefore difference is 2. When kids start hearing difference in story problems, they'll already think subtract. Same thing here, the difference in 6 and 2 is 4. And instead of having any of this mess over here, everything's nice and clean and you can see what you did, and it tracks the way your brain thinks. So if you want to break it down further, we're going to say 400 minus 20 is 380, and we still have the minus 4. Now, does it take more on paper? Yes. Does it translate into your brain and into algebra? Yes. So is it worth it to do a little more on paper instead of having a big mess that you can't necessarily even understand? Absolutely. Now I also want to show you something that I'm going to call the Darby method, because my daughter Darby at age 6 or 7 showed me this and said, "Can we do it that way, Daddy?" And I thought, what a great way to turn this into an addition problem and use your brain. So for Darby, they started with algebra tiles. So these big huge blocks are worth 100 each, and then they have little blocks that they draw. Oops. Just 10, and then 2 little ones. So that's 8 hundreds, 1 10 and 2 ones to represent 812. And she said, can't I just take away the 400 here and then take the 36 away from 1 more 100? I said, well, sure. So she did 100 minus 36 and used the 9 9 10 principle, which we'll talk about, and made this into 64, and said, now Daddy, it's just an adding problem. It's 1, 2, 364 plus the 12, which is 376. Once again, this is a pictorial version of what her brain did. So either way, either thinking it on paper this way or just in your mind, it's important to start with the big numbers and work to the small numbers. For 9 9 10 theories, look at lesson 3 and lesson 4, which will help you out whenever you want to take something away from 100 or 1,000 or 10,000. So remember, left to right, top to bottom, important to unimportant, and it'll make life so much easier when we get to negative numbers, when we get to algebra, even geometry and other things, instead of having to relearn the original stuff of adding and subtracting. Thanks for dropping by. I hope it helps. I hope you stick with it, and I hope we can stop the algorithm.